Okay, today we are going to talk about canceling rational expressions as well as stating their restrictions. So basically, if you have something in common between the top and the bottom, it can be canceled. So if we look at this, this is very simple. X12 divided by X6 can be simplified to be X6. Now before I simplify, I always need to state restrictions. If you remember, restrictions for rational functions are what the denominator cannot equal. So in this case, the denominator cannot be, X cannot be 0 because the denominator itself cannot be 0. So that was a very simple one. This one is a little bit more complicated. So this is how I want you to do these questions. I want you to factor the top, factor the bottom, and then go from there, okay? So, and before you do that, state the restrictions. Well, sometimes, if it's obvious, like this one's obvious, the restrictions are that X cannot equal 0. So for this one, let's take out what's common in the top. So I could take out a 2x cubed in the top, and it would leave 1 plus 3x4. And then I have a 2x squared on the bottom. And then whatever can be canceled is anything that's in common between here and here. So the 2's can cancel, and x cubed divided by x squared. Remember that when we divide expressions with the same base, we subtract their exponents. So that's going to be an x on top. So I'm left with x times 1 plus 3x4. So that's my final answer with x cannot equal 0. So then if we look at this guy here, so if I look to factor the numerator, there's nothing I can take out of x squared and 5, okay? So there's actually nothing that can be canceled in this one. I find a very common error is people think they can do that. But what is happening is this guy right here, he's also divided by x cubed. So if you cancel it here, you're robbing this guy of his x cubed. So nothing cancels in this expression. We can just say that x cannot equal 0, okay? Then if we look to these ones have already been factored. So we just look what's in common between the top and the bottom. So what could I take out of an x squared and an x? I could take an x out of both. It's going to cancel and leave an x on top. So I'm going to have 2 over 2 times 5 minus x. Remember, I should always state my restrictions before I cancel. My restrictions are anything that's going to make the denominator 0. When it's factored, I kind of look at it as two pieces. So for this one, 2x cannot be 0, so x cannot be 0. And this one is x cannot be 5. Last one here, it's already factored for me, so I have x minus 8 over x minus 8 times x plus 5. Should state my restrictions before I cancel anything, so x cannot equal 8 or negative 5, because both of those things would make my denominator 0. So now I look and see if I have anything in common between the top and the bottom. Well, I do. I have an x minus 8. Now be careful. When you cancel something, you are dividing. Anything divided by itself is 1. So often people think on the top it's a 0 left behind, but it's a 1 on top. Okay, and that would be how that question is done. So that's how we cancel rational functions.